Okay, so you might notice one thing is, how do I differentiate 3 like this? That is a constant, and this, so you might want to also know that, oh, there's also x like that. So let's start with x itself. What's the derivative of x? Well, that's x to the power of 1, right? So what you can do is just pull the 1 down times x to the power of 0. What's x to the power of 0? X to the power of 0 is 1, okay? So that's just 1. So when you have differentiating something like 2x, so let's say differentiate 2x, you can first pull the 2 out, and then differentiating x, right? ddx of x, and that's just 1. So the answer is 2. So you've learned a new fact, or a shortcut, is if you have something, if this is x to the power of 1, so what's the derivative of 5x? The answer is just 5, right? You can basically, first of all, ignore the 5, pull that out, and then the rest, dx dx, is just 1, right? And sometimes people treat it like this and like a fraction, but it's not really a fraction, okay? So it's really doing a differentiation process, all right? So the next question is, how about a constant? So if you want to differentiate a constant, right? So ignore the 3 first. How do I differentiate 1? Well, 1 is already, it's the same as x to the power of 0. So if I differentiate that, I need to drag the 0 down, and then x, and then subtract 1 from the power. But 0 times anything is 0. That's 1 over x, but whatever that is, it's going to be 0. So the next trick you'll learn, so this is one trick. If you have x, basically differentiates to 1. If you have if you have 1, it differentiates to 0. In fact, even if I want to differentiate 3, right? So if I differentiate, if I want to do ddx of 3, what you can think of it as is the same as, it's identical to 3 times x0, because x0 is 1, x to the power of 0 is 1, right? So it's 3 ddx of this, but as you know, this goes to 0. And that's 0. So what you've learned, not only if you differentiate 1 is 0, any constant, let's use k for constant, differentiate any constant is 0. So these are two nice tricks to remember. Okay, as a result, oops, I shouldn't erase g. Okay, so now we can do df dx like that. And so 2x will just be 2, and differentiating 3 would just be 0, right? So the answer is 2. And dg dx, right? I'll split it out explicitly. So what's g? G is x squared plus x minus 1. And now we can tackle them term by term. So differentiating that would give me 2x. Differentiating that would just give me whatever that's in front, that's 1. So as you can see over there, right? And differentiating a constant without any x would be 0. So the answer is just 2x plus 1. Okay. All right. So that's all differentiation is. And we also want to know integration. And integration is just a reverse. And the hardest thing about integration is the notation. All right. So what we really want is to reverse the process and say, hey, if I have x, what differentiates to give me x? And that's called integration. All right. So the rule for differentiation of any x to the power of n is drag down the n and make that n minus 1, right? So subtract 1 from there. So that's differentiation. So let's think about it, right? So if what differentiates give x? Well, x squared differentiates gives 2x. So 1/2 of x squared must differentiate to, because the 1/2 will just get multiplied in front, to x. So that must be the answer if I go backwards, and that's correct. So integrating x will get you 1/2 of x squared. All right. So so what we say is the integral of x is 1/2 x squared. Okay. Now let's try another one, right? So how about the integral of x squared? Well, the question is what differentiates to x squared? So x3, it usually differentiation drags down a power, right? So let's increase the power by here. So x3 should differentiate. What happens if I differentiate x3? It's 3x squared, right? Drag that down, subtract by 1. Okay. So I just want to end up with x squared. I don't care for the 3. So what if I put a 1/3 here? That seems to work, right? So the 1/3 would just cancel out that and give me x squared. Okay, so that is the derivative of this, which means if I integrate x squared, I get this. Okay. Now we can formalize a rule now if we do the next one. So try to integrate this, right, and see what you get. You can pause the video and do this. I'll reveal it at the end later. Yeah, you can do that now. And once you've done that, I will show you the general rule now. Okay. So the general rule, if you see, you spot the pattern is when you integrate something, you want to increase the power by 1 and then divide by that new power. All right. So when you integrate something, so you can see you take 2, you increase it by 1. So you first increase it by 1, and then you divide. The result is you divide by the new number. So this is the rule for integration. Okay. All right. So now I can reveal the answer. If you haven't done that yet, write that down now. Pause the video and take a second to write this down, and then I'll show you the answer. Okay, I hope you're done. So we increase that by 1, so that's 4, and divide by the new number of the new power. So that's 1/4 x4. Okay, so that's integration. So can you tell me while I'm erasing the other side of the box, what's the integral of x to the power of 100? Right, so you increase that by 1, so that's 101, and divide by the new power, and that's it. So the last thing you need to know, the hardest, sometimes I joke about, is the hardest thing is the notation. Okay, so the proper way to write this, of course, is not with the arrow. Is, let's say if I want to integrate this to this, the proper way to write this is this. So little curly sign, and then you write x squared dx. Okay, so you read that as integrate x squared with respect to x. So dx means with respect to x, like that. Sorry about the glare again. Yeah, all right. So you write that and equals to 1/3 x cubed, like that. Can you see that? Yeah, sort of just barely. All right, we'll do that. There is a small caveat, and well, it's not small because it's one of the most important thing that people make mistakes about is this. When you integrate this, in principle, integration is the reverse of differentiation, right? So if I differentiate this, I should get this. So this is an important note, right? When you differentiate this, you get this. However, let me ask you a question, right? So if I differentiate this, I get, well, ignore the 1/3, so it's 3 like this, right? And then these cancel, so I get x squared, good. But if I also, what if I differentiate this, right? I can differentiate term by term, but differentiating this term gives me x squared. Differentiating this gives me 0. I get the same result, right? In fact, differentiating any constant is 0. So that means plus any constant will be x squared. So if I integrate, I can do, the answer should be 1/3 of x squared plus any constant. And there's no way to know until there's other information you have to solve for that. Okay, so the proper answer over there, this was almost correct, but I need to add a constant. Every time you integrate something, there's an extra option for you to have. There's an extra degree of freedom over there, and that's called the integrating constant. All right. So just to be concrete, like integrating x to the power of 100, it's going to be 1 over 101 x 101 plus c. Every time, remember to add a plus c at the end, because if you differentiate this, just double check, right? You should get back this. And no matter what constant you have over there, you need to allow for the possibility of the original function that differentiates to this has another constant. All right, so that's all you need to know about calculus. We'll see how that contributes to kinematics.